Yeah, hello there students. This is the last lesson in science and it is unit point 7 to 9, electric circuits. You can find this information on book 9, page 152 to 156. Okay, objectives, definition of the electric circuits, the voltage of a cell, and then the parallel and series circuits, and then I give you a homework, the last homework. Definition. What's a voltmeter? Here. What's a voltmeter? This is a voltmeter. This is a device of a voltmeter. If you can see it, this is the negative, and these are the scales. You can use 3 or if you use this bottom here, so you can use the measure downwards. Here you see that from 0 to 3. So if you put the cable here and you put another cable here and you measure the potential difference across a battery, you should use the measure down here. So it is a device, a voltmeter, to measure the potential difference across a load or across a battery. You can measure with the voltmeter the voltage of a battery or also of a load light. You can put it here in this point and in this point. I call the corresponding ends. The voltmeter have this end and this end. This end is number 1 and this end is number 2. The light also have this end, number 1 and 2. So 2 and 2 corresponding side. I call these things corresponding ends or corresponding sides. So I connect the corresponding ends of the voltmeter with the load, and we call this connection a parallel connection when the corresponding ends are connected together. Okay, so the voltmeter is always connected in parallel with the load or with the power source, so that I can measure how much voltage is produced from this source. So this is the battery, and this is how it looks in the electric drawing design, and this is in real life. This is the battery, current comes out. This is the load. This resistance, as I told you, it represents the load. As you see, he put the voltmeter across the resistance of the load to measure the voltage, and he can put it also across the light. He likes to show you this symbol and this symbol are the same. You can put it here to measure, or you put it around the lamp, because this resistance here represents the resistance of the lamp. This symbol here, this component here, resistor, this is the resistor of the lamp. So they are just one symbol. I can put the lamp in the top of the resistor, but we want to detail here some things to make the diagram much easy. But in fact, you can put the lamp in top of the resistor, because we are saying that this resistor represent the resistance of the lamp to the electric current which is passing through the electric circuit. So this voltmeter now is measuring what? Measuring the voltage difference across the load, measuring the voltage difference. Okay, so let us go to the voltage of a cell. You have here two cells. Of course, these cells are 1.5 volt. Okay, so when I add them, when they are connected in this way, look, this is connection, I call it in series. Why? Because if this is 1, if this end is 1 and this end is 2, this end is 1 and this end is 2, you see this end is 1 and this is 2, 2 is connected to 1, 2 is connected to 1. So the ends, the corresponding ends, are not connected together. When the corresponding ends are not connected together, they are called series connection and not parallel. In parallel, no, the corresponding ends, you see this end is connected to this end, and this end is connected to this end. So the corresponding ends are connected together. We call it a parallel connection. But when they are connected in this way, they are a series connection. So if I connect these two cells in a series way, we have 1.5 plus 1.53 volt. So the power which is delivered from these two cells are 3 volt, not only 1.5. Okay, what happens if I turn the polarity? If I put plus minus, then minus plus, then I have 0, because then I have one opposite to the other, one going in this direction and the other one going in the opposite direction. So it is 1.5 minus 1.5, that gives me 0 volt. Now I have 3 cells connected in series, plus minus plus minus plus minus. The direction of they are all in this way, they are all in the same direction, the current flow are all in the same direction, so I add them all together. 1.5 plus 1.5 plus 1.5, 4.5. I have 4.5 volt here. And then I have here also something else. I have 3, they are in the same direction, but you see here I have one in this direction, and it is 6 volt. So I have here all together 4.5 and here 6. So that means 6 going in the opposite direction from 4.5. That means 6 minus 4.5. That gives me 1.5. In spite of that, I have 4 electric cells in my circuit. These 4 electric cells deliver me only 1.5 volt. Why? Because I have the 6 volt flowing, the current flowing from the 6 volt cell going in the opposite direction from the other 3 cells. And as you see, the voltmeter is measuring here the these 2 cells. Each one of them is 6 volt. Okay, it's just like an example here, an outer example. Now I like to measure the voltage here. I have here a cell and this is another cell, and I like to use this voltmeter to measure this cell. What I do, I bring a line from the neutral line and the other one from here. I put it on the polarities. I bring the black line here on this polarity, you know, the corresponding end, and bring this to other corresponding end here, and then now I can measure the one with the 3 volt. I can measure here, this is 3 volt. The Zeiger must show me now that this goes to 1, 2, 3. This the red line here must come to 1 and 1.5, and now because they are 2, I have 3 volt, then this red line have to come exactly here on the 3, on the 3, and this red line must come to the end, to the 3 here, because I have 3 volt, okay. And I used here what is, if you can see it, I used the 3 volt scale. Okay, so now parallel and series, I spoke about that. You see, series, they are connected, not the corresponding end. 1, 2, 1, 2, 2 connected to 1, so this is not the corresponding end. You know, remember in mathematics I explained to you the corresponding angles are angles which are one of them in the front of the other, exactly in the same place. This is in the angles. Okay, here in mathematics, but here we have also 1, 2, terminal 1, terminal 2, terminal 1, 2. The terminals are not corresponding. Corresponding terminals when they are 1 to 1 and 2 to 2, but no, here that's why they are connected in series here, because 1, 2 and 2 connected to 1, and then 1 to 2 and 2 goes to the battery. So they are connected in series. In parallel, if you have this end 1, this end is 2, and this end is 1, and this one end is 2, so the 2's are connected together and the 1's are connected together, we can say that the corresponding ends of the loads or of the lamp are connected together. So you can, in electric circuit, you can say that this place here is 1 point. This is just like 1 point, and this place here is just like 1 point. Okay, you see this point here, what I mean. So this looks like this point here, and this here looks like this point here. So this is the parallel and this is the series. Okay, there are a lot of characteristics about a parallel or a series circuit. What is interesting for you, what's important for you to know, that in a series circuit, in a circuit which is series, the current, when it is 2 ampere going in this direction, it will stay 2 ampere along the whole circuit. It will never change. 2 ampere here and 2 ampere here, it will never change. But in a parallel connection, the ampere, 2 ampere will be separated. 1 ampere go in this direction, the other 1 ampere comes in this direction, and they will be added again in this point, and they will go back also 2 amperes. So each load here will have 2 amperes going through them, and each load here will have the half amount of current going through them, because they are connected in parallel. This is what's important to you to know. Also, what is A? A stands for ampere. This is the electric current measuring unit. We measure ampere, this A here stands for ampere, and I know this is electric current. And V stands for voltage. V stands for voltage, which means the measuring unit. Voltage is the measuring unit of potential difference. Current in series circuit will stay the same, but voltage not. current in a parallel circuit will be divided, but voltage not. Voltage is always opposite from current. If the current here stays the same through the loads in a series circuit, the voltage will be divided in two. The voltage here depends on the resistance of this lamp, and the voltage here will depend on the resistance of this lamp. Okay, so the voltage is not the same, only the current going through them is the same. In a parallel circuit, the current will be divided in two, but the potential difference, or the voltage across this load and across this load, is the same. Is what? The same. So if you have here the cell, for example, 1.5 volt, so here will be 1.5 volt and here will be 1.5 volt, and here no, the voltages are different depending on the because they are connected in series. End of unit questions, page 159. Try to make question number 10.3 is very important. Okay, thank you very much. This was the last video for our summer school, and I wish you good luck in the test, and thank you.